Awesome. And in number 12, we're finding missing angles in a rectangle. So the big thing you need to recognize in a rectangle is just made up of four isosceles triangles. So when you have isosceles triangles, your base angles are going to be congruent. So those two would be congruent. This one and this one would be congruent, so on and so forth, all the way around there's four isosceles triangles. So then I just start using properties of triangles to find those missing angles. So like for number 12, I would first look at this 1 because 1 and 40 are both base angles in an isosceles triangle. That's what type of triangle this would be classified as. Then that means that angle 1 is also going to be 40. Then the amount of degrees in a triangle is still 180, so that means that angle 2 is going to be 100 because 80 of those degrees are taken up. There's still 100 degrees left for that triangle. Then we move into angle 4. Well, angle 4 and 2 make up a straight line, which means that they are supplementary. So angle 4 is going to be, if 2 is 100, 4 is going to be 80, which here we need to find some information that we don't need to solve the problem, or we need it to solve the problem, but we don't need it for like the credit of the problem. But we need to know that 4 is 80. That means the angle opposite of it's also going to be 80. Now we're back to an isosceles triangle. Well, 3 and some other angle are going to be the same. So these two are going to be congruent. And then 80 degrees is taken up. So I could take 180 minus 80, which leaves me with 100. So that's how many degrees are for both those angles. Both those angles need to be the same. That's going to mean that both those angles are 50. So then angle 3 is going to be 50. So when we get into that rectangle, the rectangle starts to produce perfect isosceles triangles. And then we can use the base angles theorem of an isosceles triangle. Hopefully that helps. And then I can continue taking any more questions.